Hello and welcome to Microsoft Virtual Academy. We're presenting some courses on XAML for Windows 10. The first course is going to be around layouts. My name's Darren May and I'm president of Crank211.
My name is Jerry Nixon, developer evangelist here in the United States. Welcome to America.
It's my first time. Go easy on me.
Now, specifically, we're going to be talking about layouts. This is layout fundamentals. There's quite a bit to talk about.
Yes, indeed.
Before we do, let's kind of lead in so students know what they can expect and what we expect of them.
Sure, certainly. So as you mentioned, the course topics, we're talking about layouts. So this particular one is layout fundamentals. We've got another two as part of this course. And in terms of expectations, we're looking for our target audience to obviously be wanting to make apps for Windows 10. Suggested prerequisites, they should have a basic understanding of C# and also a basic understanding of XAML, though we will be covering some of those fundamentals as part of this particular session.
There are some things we want to make sure they understand, but we certainly aren't going to start from scratch. This is what XAML is, except for that one slide that says this is what
XAML is, yeah. Other than that, though.
Other than that, it's perfect. If you've never said file a new project, Windows 10 app or universal app, then this really isn't the course that you want to start with. That being said, if you're a fast learner, then maybe it is.
Dive in. So we've got a couple of recommended resources here. dev.windows.com, that's the place to go for pretty much everything related to Windows 10 development.
Look at that, it's HTTPS.
Yes, I know.
Is that for real?
It is for real.
Secure like that?
Yeah, it gets redirected. Who knew? Who knew? And also, we've found a particular link on MSDN, which takes you straight to the Windows 10 XAML overview as well. So
it saves you a lot of searching, because that article sometimes can
get hidden behind all of the others.
Yes, exactly.
Okay. So let's talk about the first part of this, layout fundamentals.
Okay. Well, let's begin with really let's talk about just a summary of what XAML is. All right.
Smooth.
Now, what does XAML stand for? It's funny, we've gone round and round about this because for a while XAML stood for the Extensible Application Markup Language. Everything had some sort of XML kind of oriented name. Then that was dropped and it was just XAML. Now today, if you go back to the documentation again,
it says Extensible Application Markup Language.
We're there again. Yeah.
We're there again. In reality, it doesn't really matter what it means.
No, it really doesn't. But that's what XAML starts with. But the best thing just to think of is it's an extension of XML that is sort of like another syntax for C#.
Yeah, and its purpose in reality is to allow us to instantiate objects and set properties on those objects.
That's right, and to be able to handle events, or at least set up the handler for events, and all the stuff that we would typically do in code, we get to put in a declarative way so that it can be understood by designers, right? Not just designers the people, but designers the software, so that they can render design time experiences for developers without having to execute the code underlying.
And I think the phrase that you mentioned there, declarative fashion, is one of the key things, certainly for people who've been building user interfaces for a long time. It's very nice to be able to separate out the definition of your UI from the behavior.
Yeah, that's exactly right.
So XAML is very, very powerful, and we hope to give some insight into some of the power of this capability throughout these courses.
That's right. App after app, we're all choosing XAML because XAML has a lot of power and a lot of future, and so understanding it, a lot of value in that. So. At its basics, let's talk about how we set up an individual page. And so we know we have a lot of namespaces and things to look at. And honestly, some people will say file a new page and never even look at those until there's a necessity. You're like, you add a namespace. You're like, what do you mean? So here are all the namespaces that you get right out of the box when you create a new page in an app for Windows 10.
Absolutely. And the reason we have namespaces is because, as you mentioned earlier, this is a language that's derived from XML. And namespaces are used very persistently throughout XML.
And so line 1 through 5 are all representing namespaces, but to be clear, the very first one is representing the default namespace, meaning you don't need a namespace. So every element you see in a XAML page that doesn't have something : preceding it all uses this default namespace, which really represents, look at that, all the way back to WinFX. It's the spec for XAML that goes all the way back to WPF.
Yeah, well, Longhorn.
Yeah, all the way back to the beginning.
Yes.
2006, the introduction of WPF.
Yeah.
And so that's where things like grid come from, StackPanel, button. We'll talk about those more, of course, but that's the gist of where all those come from. But then I might need other things. And so talk to me about X, because X is pretty cool.
Yes, X is used very frequently. It defines your main programming constructs, and also gives you access to data intrinsics, which is just a fancy way of saying the data types that are common to .NET or WinRT, such as Boolean and string and so on and so forth. So, we commonly see it in terms of referencing name and so on.
Yep, like X:\name.
Yep.
Right. That's right. And so,
and we'll cover that in another slide in terms of more detail.
Yeah, you could almost look at it as almost as part 2 of the WinFX, the first one, because that's kind of the complement that kind of completes the entire name.
Yep.
All right, so then we have, you can see in number 3, it says XML namespace local. And so local is an arbitrary string. So is X, by the way. All of these are arbitrary strings that are just kind of chosen when it comes out of the box. You could change these to whatever you want.
Yep.
But nonetheless, local represents the local namespace of this page. So for me, for example, I put my pages in a views namespace. So it would be in it would show views. So this one you can see that right out of the box, it's using :app10. That's just like the using statement inside C# at the top of a class. And it might say app10.views, or it might actually point to another PCL you might have as well. Either way, it's just showing the local namespace.
That being a portable class library.
Yep, that's right. And so when I start interacting with code, I need to find the classes inside my assembly. I do that by putting in these namespaces. This one's right out of the box for local.
Yep. Okay, so the next one, our D namespace. So this gives us access to types that are contained within the blend namespace. So give us an example of some of those.
Well, honestly, data context is one of them.
It's the most common one that we use.
Yeah.
Giving us a design time data context.
Yep. Design width, design height is another one that we can use so that we can see things in the designer that don't really represent what they're going to look like at runtime, but they look like what they need to represent design time so we can see them. So you need it a little bit wider while you're designing it. You can say D:\display height. I think that's what it is.
Yeah, I think so.
I think that's right.
Yep.
And so the right partner with D then is MC. And MC is nice because it allows us then, you can see right below it, it says MC:ignorable equals D. And it basically allows us to use the D namespace, but ignore it when it goes into runtime. So that design width, design height, and even design data context are not emitted at all into a release of your application. They're only there for you to use at the design time. So D and MC, or really the blend and then the markup compatibility, are all there for you at design time. And they all kind of get stripped away because it knows what to do with it properly. Now that MC:ignorable equals D is not a namespace declaration.
No, that's actually setting an attribute value.
That's right. So ignorable is, I don't know what that is. A property? Is that a property? It must be a class.
Must be an element for sure.
Yeah, or maybe it's an attached property.
Yeah.
It's funny, I've never moused over that one before.
Yeah.
But it allows you to say which namespace don't emit into release.
Yeah, it's basically actually an attribute, isn't it? It's an attribute of the page element.
Yeah, I'm seeing. Yeah, you're absolutely. Oh, that's right. It's an extension of the page. That's right.
Good job, we're professionals.
Yes. Hey, we can. We got the whole crew here today.
Exactly.
Nice.
Okay, so let's dive a little bit deeper into the X namespace. So that gives us a number of key properties. We did see in the previous page XClass, which allows us to specify the code namespace and class name for the code behind for a XAML page. So obviously that's very key to be able to tie those things together.
In fact, Danny, switch back to my slide for just a second. I want to show you that. So see at the top I've got that page, but it says X:class. That's me saying where to go find the code behind, or the actual C# that's the companion to my XAML file.
Yep.
Pretty neat what X is.
Absolutely. So if we flick back to mine, we can see the X key there. So that's used to create a unique identifier for an entry in a resource dictionary. And we're going to be covering resource dictionaries in some depth a little bit later. But fundamentally, if you imagine a key value pair or regular C# dictionary or whatever, this represents the same thing. It's the ID that you would use to find that particular resource.
And I think it's worth at least saying, even though they're not next to each other, key and then the third one down, name, those are friends of each other.
They are friends.
Yep.
They don't do the same thing precisely.
They certainly are a place of confusion at first until you understand how exactly they work. XName is representing the field actual value in the code behind. So if you have some sort of class that you are instantiating or somehow creating or declaring inside your XAML, you're going to give it an XName, and it's going to have a field that you can reference then in code behind.
Yeah, so for example, if you had a grid control on your page and you gave it an X name of mygrid, then in the code behind you would be able to go mygrid dot, and that would give you the instance properties and methods associated with the grid class.
That's right. And so keep on going there. There comes XUID, and you would think, well, here's a third way to name an element, but it's really not a third way to name an element.
Yes.
This isn't an ID at all. This is special just for localization. And in all reality, I could have two text boxes, say, with the same XUID. They're not a unique way of identifying something. They're a way of associating it to some sort of localized resource.
Yes.
And we'll show more about that in other modules. But that's just so you can see where X colon comes from, I mean.
Yes. Now, new to the X namespace is XBind.
XBind, yeah.
Yeah, new for Windows 10.
We've always loved data binding inside XAML.
It's one of the most powerful aspects, I think, that we as developers really enjoy.
Yeah, and you can see that syntax over on the right, that little squiggly into binding. And so that is the classic syntax, not the new syntax. Still works, of course. Everything's still great about it, and the reason developers love it is still there. But it's not the most performant way to data bind. That's because the most performant way is XBind, a fully compiled binding, no reflection going on that causes some of that lag at runtime if you have a lot of bindings.
Exactly. Especially useful if you've got many data repeaters and showing lots of different values in a repeating way.
Yeah. It wouldn't make sense if you come across an app or a developer is using binding and to say your app could be so much faster if you would only use XBind if they're using two bindings.
Yes.
Yeah.
Yeah, there's going to be some improvement. Is it going to be measurable to the common observer? Probably not.
Probably not. I would say even if they're using 50 bindings, you may not be able to really notice.
What about 51?
Well, you've crossed the line.
Okay. So, the final things that we want to touch on in this particular namespace is the XAML intrinsic types. And really, that's just a fancy way of allowing you to access booleans, strings, other data types, and also the special data type, really, null. It's kind of a confusing one because you don't think of null as being a data type, but we needed a way to be able to express null as a value and be able to assign that inside XAML.
And even though this is XML, don't confuse that with nil. This is null, which really is it's really the managed null, or it's the null we know in code.
Yes.
Yeah.
It's not zero.
And it also doesn't mean not set like SQL.
Yes.
It's none of those things.
Yeah, so don't get confused by all the things we're saying to confuse you.
Right. If you could just go back 30 seconds and then skip 30 seconds, I think you'll be all right.
Perfect.
Great. So let's go to markup. We saw how you could bind, right? That's kind of squirrely brackets. What do you call those? Curly brackets, probably. I think.
Yeah, I would call them curly brackets.
I don't know
squirrely
why.
brackets kind of seems a little bit strange.
I've said squirrely for so long. So anyway, that's referred to as a markup extension. It's what you can set or what you can put inside the property of some or the value of some property.
And it's probably worthwhile pointing out here that if you've come from other versions of the XAML dialect,
like Windows Presentation Foundation.
Exactly. Then you may be used to markup extensions that we're not listing here. It's fair to say that there has been a reduction in some of the extensions that are available in terms of efficiency, in terms of being able to better leverage the platform.
Yeah.
So
where we're like, that just does not perform, we're not going to put that in. Usually it's a performance reason.
Usually, and I think it's also, as we go on through these modules, we'll also cover some of the things that were once something that you had to handle inside your XAML, such as the focus layers, but have now become intrinsic to the platform, and so they're not exposed up in a way that you would leverage them.
Yeah, and it seems like you can always trace them back. It's like follow the money. In this case, just follow performance.
Yes.
You can usually see why things have done. All right, so we have a couple of these extensions that ship right out of the box, and by a couple, I mean 6. So the first one is binding, which we already talked about, data binding. And then we have this ability to access resources, and we have 3 ways to do that. And the first is through static resource. So these are things that don't change. And you might think this is the opposite then of dynamic resource, but there is no dynamic resource. That was a performance crippler in WPF.
It was.
And as fun as they were for developers to use, they were painful for users to experience. So anyway, static resources is a way for me to reference something either by name or by key that I am declaring inside some resource dictionary. But special to that is a sort of changeable resource.
Yep.
That's the theme resource.
Yes.
Theme resource is it's a platform-controlled dynamics. So every time you use a theme resource inside any type of control, as it's being created, it knows to wire up an event listener to go ahead and update that if it's changing the theme layer.
Examples of themes are, in the Windows 10 preview, one of the recent previews.
Yeah.
It can pick out an accent color from your background image and update your theme, which would update your title bar and your highlight colors and so on and so forth. If your application is using a theme resource for there, then those colors would automatically be pulled into your application.
Yeah.
May work in some applications. In some others, where they're heavily designed and branded, it may not work. So you may not want to be using theme resources inside those scenarios. Just
maybe at the highest level, the theme might be light or dark, and so then that wraps many different styles together that you might get together.
Yeah, and of course for accessibility, high contrast as well.
Yeah, high contrast, and the millions of variants of that as well. Okay, so those are the. Oh, and then let me just jump on down, kind of out of order, and say another one would be custom resource at the bottom, also meant for accessing resources. But in this case, you're not accessing theme resources. We're probably not even accessing dictionary resources. This is some sort of coded, intended for your application.
Yes.
What are the odds that a developer is going to use custom resource in their app, you think?
Seems very unlikely. It's actually a relatively complex activity. You've got to create a new class that derives from a custom resource base. You have to implement the get resource capability. And you also need to register it once in your application during its startup. So it's something that I think could give a lot of power. Say, for example, you had some cloud-based resource that you wanted to be able to pull in dynamically. Say you had an app that was branded across multiple customers, and it needed to determine what branding to show at runtime. Then I could see this being a scenario where you might leverage custom resources.
This really is one of those things with great power.
Yes.
Don't say it. You know what I mean? It's just, that's too cliche. But I mean, the reality is you could cripple your app by mistake just by overusing this, when probably 1% of all the apps in the store maybe engage in this at all. The rest somehow manage to be awesome without it. So your app may be too. But it's good to know that it's there, because if you see it, you don't want to be confused by it. All right, let's talk about template binding.
Yeah, template binding. So we've mentioned binding, Xbind. Template binding is a special case. Really supports control templates. And the reason for this is it gives you performance again.
That's right.
Back to performance. It gives you a much more optimized evaluation of some dynamic binding scenarios. And why is it dynamic? Well, when you're building a control, it's abstracted from the type of data you're going to be presenting. And so it still needs to do some sort of dynamic determination of what data is going to be going on.
That's right.
But it's optimized for a particular scenario, one way, I think, in particular.
Now, we had a previous course where we were talking about templating a control and being able to reference back to those. And that's really where template binding comes in. And that's a little bit more specific of how when we dive into it. But this is, when you see it, you're like, why is there template binding? Because it was made for this. And there are also some limitations around Xbind when you get into templates as well.
Okay. And then carrying on in the template binding, we also have relative source. What does that give us?
Relative source allows us to see what's nearby. So if I were a WPF developer, I might like the idea of being able to see my ancestors one way or the other, right? So that's not what this is about. This is about being able to see me. I might need to bind to something I have. So one of my properties is going to be bound to another property based on maybe a converter or something like that. Or I might go all the way up to my templated parent, which is very valuable, again, if I'm back in the content template mode. And so I have that as well. So those are the only two modes that I get out of relative source. I can either go to myself, or I can go up to my content template. Control template.
Control template.
Control template.
Yes.
Yeah. Anyway, so those are all of our extensions.
Yes.
The syntax on XAML is pretty straightforward and easy, especially if you understand how valid XML works. But I think it's worth at least looking at kind of how you might put together simple scenarios.
A quick refresher. So if we look first and foremost, we have the elements. So elements, very much the same as you would do it in XML. You'll notice button is not prefixed with a namespace. That's because it's in the default namespace.
That's right.
We've got the two variants here where you've got the open and closing element syntax and the self-closing element syntax.
Right. That's nice. Yeah. Not everything has to be open.
Yep. So we also have the ability to create containers. So Canvas, which we'll cover in more depth in a little while, happens to contain a button. So we can show how we have this nested capability within XAML.
Yep. And so what you're really setting there is a property that is implied in Canvas. So Canvas has probably children, I guess, since it's a container.
Yes.
Has a children property that you're not setting the children property, you're adding to that property's value.
Yes, there's kind of as you mentioned, an implicit association between the content and mapping that to the children collection.
Yeah, that's right. And then, so setting properties, you can set properties in a simple or in a rich way. And so you can see here in height and width, we're setting them straight to 100. And of course, we know height and width are both doubles. And so 100 is not a double, it's a string.
Yeah, it's a string.
But we also know that there's a value converter that it's a
type converter.
A type converter that automatically reads these and tries to set them properly. Obviously, if I said 100 or 10K, that's not going to work, right? Then convert it into 10,000 or whatever. But it's nice that it has that there, so we don't have to type everything as we go through. But then you can see rectangle.fill isn't setting it to a value of blue. It's actually setting it to a class of solid color brush.
Yeah, and in solid color brush, we're setting its property equal to blue. So we have a type conversion going on there because blue is a string.
Yeah.
It doesn't map to an enumeration. And in reality, color comes from the colors enumeration. So there's a type converter that's taking that blue string and converting it to...
The coding experience is pretty nice. I say color equals, and it gives me the enum because it expects it. But yeah, I get to put in a string. And in fact, it's good just looking at this and saying rectangle is a class with three properties, the third one being fill. And then solid color brush, it's a class with a single property of color that I'm putting into blue. Of course, there's many other properties, but if you just look at it like that, it can feel a little bit like C# syntax.
Exactly, and this is where it comes back to XAML is an object instantiation language. We are defining these objects and the properties that they will be set to once this XAML is passed and executed.
Sometimes the way that you interact with XAML needs to have more information than the native class actually has. So for example, if I look at the button class, the button of course has click events and it has size and all that sort of thing. But what it doesn't have is where it might go in Canvas. So if you look here at attached properties, I'm able to say canvas.left. And that's because something very unique to XAML here is the ability to add a property to a class without having to extend that class. And we call those attached properties. And it's the ability to, really it's static behind the scenes, but to be able to practically put information on a class and be able to hold it and keep it associated to that particular instance. Yeah,
and built-in controls have this, and you also have the ability to build your own custom controls that have those capabilities too.
Yeah, it's like grid column and things like that you see those a lot.
Yeah.
Also, a lot of the automation properties, or those are for accessibility, they're all attached properties so that they kind of go to every control they need to. Pretty nice.
Yeah.
All right, collection syntax. Well, we kind of
covered that in containers. Yeah. I think in containers we were really talking more about the concept of an element can contain other elements. On the collection syntax, we were really emphasizing the fact that behind the scenes, a collection is being instantiated, and then the two strings hello, or the two text blocks with the content of hello and content of world are being added to those collections.
Yeah, that's right. So I tell you what, let me open up Visual Studio here. In fact, let me show you this. I'll pull up a blank application. Let's just build out what a button would look like and how it might be. It's nice and simple, but I think it's worth looking at. All right, so let me pull up the main page here. Very nice. So I'll add just the button control.
You want to zoom in on your text a little bit so it's easier to see?
Terrific idea. And in fact, let me see if I can open up the designer here. Let's see if I can. I'm sure I can. And so you can see the button is right here. It's on the left. And so obviously we'll talk more about laying out and things like that. So we're just going to take it where it is today. I'll zoom in just a drop to that too so we can see that it's perfectly empty. And so I could set, let's say, like the text property is what you might look for. Yep. But it's not text, it is content that I want to set. And so content is the implied default property, so I don't have to say button.content, although I certainly could. In fact, for the sake of super clarity, I'll go ahead and do it, but it's also implied, so I don't have to. And so the first thing is, because I'm going to have more than one element, I need some sort of container.
Yep.
So I'll pick the stack panel, and I'll make it so it's horizontally oriented, so it goes left to right. Okay, so now the content can take one element in it, but the stack panel can now take multiple elements.
Sounds good.
So I'll start with just putting in a text block. That's the simplest way to show text. And let me see. It's let's see. I got a little button here. It's got a save icon, and then it's got the save word. So I'll just say save, just like that. Boom. There's the button with save. Of course, it doesn't have the icon because we've only put the text into it. And I'll just add, what is it?
Symbol icon.
Symbol icon. And I think it's just
icon?
symbol. Is it?
Or
Save. Let's see what this does.
Yep.
There you go. Perfect. And then I can go manipulate. If it needs margin or padding or color or all those things, I go in, but that's not what we want to show. We just want to kind of show it just at its basic. How would we start setting up a button, right? This is a simple control like any other. So here's the button, And if here's where I would set a complex type. So this is a property where I am actually passing in something complex like this that has nested types of its own. If I had a very simple type, I could change just the background to red, and now I can set both a simple property and a complex property.
Yeah, and as you mentioned, you don't actually need button.content. You could delete 13 and was it 18, and everything would work just as well because it's implicit.
That's right. Content is already set. If you could look at the definition of a button internally, you'd see that it says if for the default content, it goes into the content property.
So we've spent some time and we've talked about how succinct XAML is and how it makes life a bit easier to create the declaration. Why don't you show how to actually create that same layout?
Oh, you like do the same thing in code behind?
Yeah.
Oh, that's a great idea. All right, so let me, let's see. I'm going to comment this out just so we don't have to worry about it. And so that's, I don't know the keystroke on this machine.
I'll just press the icon.
Just push that right there. And I will go into code behind and we'll build it from scratch here. And so I'll do it in a loaded event. I'm going to spell loaded the normal way. There we are. And I'll say, first we create a button on the outside, like so.
Yep, you want a var.
And then its background, thank you. Remember we set the background equals, now it was so easy for us to say red.
Yes,
right?
But we can't say red.
We have to build the entire thing out. So in this case, it's a solid color blue brush. Solid color brush, that's right.
And you're going to pass in
colors. Of course, that namespace is available to us, but is not by default. So I'm just going to add a using statement at the top. So it'll be colors dot, and it was red, I think, right?
Yeah.
Perfect. All right, so now we've got the button with no content in it, but we've colored it red.
Yep.
The next thing is say button dot content this time equals a new stack panel. Actually, it's going to be tricky. I better build a stack panel out first.
Yeah.
Var stack panel equals new stack panel. And then the only property we set inside that was its orientation.
Yeah.
And then we sent that to...
And so again, notice we said just horizontal. There's a type converter that takes horizontal and makes it into that enumeration value.
That's right. It's pretty nice. And so now we can say to the stack panel, it has its children. We'll add the first one, and that first one is going to be the new symbol.
Icon, yep.
Like so.
Symbol icon.
Oh, yeah. Thank you. And then inside that will be symbol, which, of course, gives us this nice enum that we didn't have to mess with inside XAML.
Yep.
So you can already start to feel its verbosity. You know, you're like, oh, well, it's all obvious, but it's kind of a pain. And let's do one more. Stack.children.add. And we'll do the same thing this time with a new text block.
Yep.
And in, just like that. And now give it a text value of save. But it's a string, so I'll put it in quotes. Like so. Yeah, there we go.
Yeah, it's always useful if your demos compile.
All right, so the last thing will be to put the button, or put the stack panel inside the button.
Yep.
Button.content equals stack panel. And there was, even though we didn't talk about it, the other thing that we did was we put the button inside the grid. There was already a grid out there. I'm going to have to give a quick name to it. Not called deferred strategy. That's terrific. Let's see.
Did somebody put a different language keyboard in front of you?
No, but the end is different. Is in a different location than my keyboard. All right. So I will call it my grid. That's just so we can add the button to it. And then right here we'll just say my grid dot children. Right, dot add, and then I'll add the button to it.
Okay,
all
so
right.
If you run that up, that should give us...
Well, perhaps more importantly, let me go to the designer and show you what we've done. Completely not there, right? Yes. So there's the value in declaring it, if for nothing else, for a full design time experience.
Exactly.
So obviously you're not going to get all of this this stuff in the designer. So that's a bummer. Let me go ahead and run it. Great point. I'll hit F5 here and let that spin up. It's building right now, Darren.
It's tense, nervous anticipation.
It's complex parsing going on right now. Optimization is
Hamsters are now running whilst the compiler is spooled up.
And look at that. It's red like you would expect. Both controls are inside it. So really, it's the same effect. You know, no click event, of course, yet.
Yes.
It's the same effect as if I had done it all in XAML. Only XAML is nice and easy to read. And even though I believe, of course, C# is easy to read as well, it's certainly not as quick, terse, and doesn't give you the benefit of design time.
Exactly.
Great. All right, so that was the demo, and actually we had some backup code, so that's beautiful. Nice. All right. Let's talk transition just a little bit now. So that's just the concept of controls and syntax.
Yep.
Let's talk about layout.
Yes, indeed. So just kind of refreshed a little bit on XAML itself. And then that leads us into the major discussion we wanted to have in this particular module was, why do we need layout controls? What is the point of it?
Yeah, so it's really about where things go. How are you going to determine where, so I've got a button, now I need to put it in the top right corner. Now I need to make it so that it goes, or I have 15 buttons, and they need to line up nicely, and they need to behave well when people resize the window. And I need some sort of control to make sure they look right, they're laid out properly.
And of course, you know, in the evolution of development environments, operating systems, and so on and so forth, layout has become a much more complex scenario.
Yeah.
Now, if we think back to Windows Mobile 6, when you had this tiny little square screen and you had very little real estate to actually position anything, it wasn't too much of a problem. Now we have applications in the Universal Windows platform that can run across...
they could be on a phone or a 4K monitor.
Exactly. And so not only do we have to think about, okay, these things can be scaling up and down, I actually have more real estate to place things in certain layouts and so on and so forth. So fundamentally, you don't want to turn around and say, okay, I'm going to design for a screen the size of a postage stamp and expect this manual positioning and fixed width layout to be suitable for a 4K TV.
Although you do have the option for fixed. So there's two types of layouts, and that would be both fixed and manual. No, that'd be a third one as well, and there's this dynamic.
Yes.
And so, but if you do go with this fixed or this manual idea of, I'm going to put something in pixel 2.2, and I'm also going to put something in pixel 105, then those locations will look perfect until you start having these scenarios where you're having awesome devices that now all of a sudden everything's over in the top left corner.
Yes, absolutely.
So not responsive, that's the word we're shooting for.
Not responsive. And really, we want to build responsive UIs.
And when we talk about layout, we're really talking about a style of control, a type of control that has many children, just like we were showing with StackPanel. And inside that control of its children, it handles those. So it doesn't handle everything. You don't have a layout control that makes sure your entire thing looks correct. It's just really responsible for its children. Yeah.
Absolutely. And you're not restricted to just one of those. You know, you can have many of those panels within your application as well to have varying layout structures in different locations. But this layout thing, it sounds like it's not particularly straightforward, because if it was, then we would just do manual layout. Why do we need the controls to actually manage this process for us? Well, I think the reality is, as you mentioned, there's a relationship between parent and children. When you position your UI, you're going to allocate specific areas for controls, and your container controls are responsible for laying out their children.
And I like this dialogue that we have here, because it really is how it goes. The parent says to the child, how much space do you want, right? I mean, just tell me how big you're supposed to be.
Yeah, and that can be without any constraint, or you can supply a couple of constraints to the child. Yeah,
that's exactly right. And that kind of depends. You know, sometimes a layout really is infinite. You know, you can scroll as far as you want to. Sometimes it has to fit inside a little box.
Yeah, so say in this scenario, the parent is a stack panel and the child is a button. So the stack panel is saying, hey, button, how much space do you need?
And here, the child says right back, I would like this width and this height, to which the parent says, no. That is way too big for what you need to fit into.
Yeah, but let's think about, okay, why would it be saying what width and height it wanted? If we think back to the demo you just did with the button, you've got a symbol icon in there and you've got text. That forms the basis for the size that the button is asking for.
So in that case, the button asked its children, how much space do you need? And it said yes. In fact, the button inside a grid, the grid asked the button how much space it needed.
Yes.
And the grid said yes as well. Nothing was too big. Not yet.
Okay. Once the child has reported back to the parent saying, hey, in ideal scenarios, this is the space that I want, the parent then starts to think about constraints and other children. So, you know, in the particular UI you just built, the massive, incredible UI.
I call it the red button UI.
The red button, that's a good idea, good idea.
Don't push it.
The red button only needed a small amount of space, but the application could provide the entire surface to it.
That's right.
So the button was, the grid was, okay, you have as much space as you need, draw away. If you'd had hundreds of buttons in there, and they'd all been specifying that they all needed different space and layout, then your panel has a lot more work to do to work out where to put things.
And of course, a parent panel is a child of a parent somewhere. And it can only do so much. So even if it was totally trying to favor its children over everybody else, eventually things are going to be clipped because there's just not enough space to put just anything out there. So if a child asks for more than a parent can give it, then it will still render, and then the edge or the top or the bottom or whatever won't render, won't show up. It'll be off screen.
Exactly. So ultimately, the parent is going to tell the child where it needs to be drawn and how much height and width it has available to display itself in.
So let's talk about the child layout properties. So that's where we kind of move into what is it we're actually setting. And so naturally, it's the height and the width, but there are a handful of types of height and width that are really interesting, and developers are typically getting them wrong, right? So I think a quick discussion is pretty good. All right, so the height and width of something. Now we have a little note here. Try to avoid setting it of the layout control. So this is me saying, you know, my grid is this column is 200, this column is 200, and this column is 300. Well, that's pretty great until it gets smaller than that or larger than that, and all of a sudden you've either got gaps or clipping. And so that's why we say that. Sometimes it is important.
Sometimes it is, and to be honest, a feature of Windows 10, the effective pixels, has reduced some of the restrictions one would normally have associated with specifying height and width, because effective pixels allows you to be abstracted away from physical DPI of your device and the physical dimensions of your device, and allows the system to project what size each PX representation inside of your height and width actually physically is presented on a particular device.
That's right. And so another we have is this idea of min-max size. And so min and max really are a way of saying back to the parent that no matter what you ask, I can never be smaller than this, right? It's more of a warning that they're going to have to clip. And then max says, you can give me all the space you want, but I'll never get bigger than this either, because this is how I'll be optimized, right? Inside this range.
Exactly. I mean, when you're designing the your layout, there's going to be areas where you're going to be presenting data where practically the data is going to be useless if you have less than a certain amount of space. And that's the idea around these things. And equally, you know, there's no point making it bigger than this because you're stretching one sentence across an entire screen. That makes no sense.
Something like that.
Yeah.
All right, so those three are actually quite easy, right? Everybody understands height, width, min, and max height, width. That's easy.
Although the fact that you can specify auto on some of these things is a little bit confusing, because if you expect your height and width to be determined by another container, then setting something that actually isn't a number sometimes can be confusing.
Yeah, in this case, it's almost like null, unfortunately.
Yes.
It is like not setting height is the same as setting it to auto. And as soon as you do that, you're allowing other controls to manipulate its height for you.
Yes.
You can still create this range of min-max, of course, that it would be inside. But we have this other three sets of desired size, rendered size, and just for the sake of saying size 3 times, actual size. Right? And so those three, now what is the size of your control if you have a desired size, a rendered size, and this actual height and width?
So, as we mentioned before, there is this discussion that occurs between the containing panel and a child, where the container says to the child, how big do you want to be? After this particular phase has been complete, that is what the desired size is set to. So given, say your text box, or your button rather, in that previous scenario, the button says, hey, this is the size I would like to be.
Yeah, and so that's the desired size. It has no relationship to its actual size, because the desired size is what the control says, this is what I want to be. That has nothing to do with rendering. So along comes render size.
Yes. And so during the second phase of layout, which is arranging, which we'll cover in a moment, that is the actual size that your control is rendered.
Yeah.
This is the outcome of the measure and the arrange phases. Interestingly, actual height and actual width, although they're exposed up, are just accessors into the height and width of the render size.
So there aren't really three, there are only two. Rendered size and actual size of height and width are all the same. They're just easy accessors, probably for the sake of binding and things like that.
Yes.
And it's worth saying that rendered size is the true size of the control, but this is where developers get caught. That value is sometimes null or empty.
It's a transient value, unfortunately. That's it's output as part of the completion of layout. So the only place you can actually rely upon it 100% being accurate is in the layout updated event handler for a given control.
Yeah.
Which can be
is what it
problematic
is.
sometimes.
Yeah, it is what it is.
Yeah.
So you might do it on loaded, right? Where you have a control and you're like, oh, wait till it's loaded. But that's actually still a little early, right? That's still not the right time. That doesn't mean rendered. It just means loaded. And so now I'm testing for whatever it's, I don't want to test for desired size. I'm going to go straight to rendered size. I can't test height and width because those I left as empty because they're auto. I just want to see what its true size is, so I'll ask for rendered size, and I'm still too early. I'm still getting back empty.
I mean, sometimes you'll see in code people actually directly calling update.
I think this is half the questions on Stack Overflow are dedicated to this one property.
Yes. I mean, sometimes you see people calling update just to make sure that the value in there has just recently been updated.
Yeah, that's right.
So, you know,
because it's synchronous, and so they can wait for update to be completed.
Yeah, so you've got a much better shot then. The problem with that is then you're doing additional layout cycles that you don't necessarily need to have.
Yeah, you're sort of forcing it to happen.
Yeah, and so from an efficiency perspective, it starts to...
when is the right time to ask for size then? You wouldn't do it at loaded. You would have to attach to layout updated.
Yes.
I mean, if this is really about manipulating its positioning, that's the right time to do it anyway.
That's the right time
after
to do it.
layout. And we'll talk about different ways of moving things around too, of course.
So one of the other things that we had on there was also to note that in the main, and this isn't true in every scenario, but in the main, most elements try to render...
In the main meaning on the whole?
Something like that. Elements try to render as small as possible. So a rectangle without a specified height and width will ordinarily be of 0 size, except if it's inside a grid where it tends to expand to fill the available space.
Yeah, the container will control that a little bit.
Yes.
And kind of influence it. All right, so there are a handful of layout properties that are worth understanding clearly. Horizontal and vertical alignment really are the ones you'll be using all of the time. And so horizontal allows the standard of what you would expect of left, center, and right. And vertical allows kind of the standard of that as top, center, and bottom. Each of them, though, has this idea of stretch, which basically says go, for horizontal, go left and right as far as you possibly can until basically your parent tells you to stop. And so then it stretches out as far as it can. It's worth saying that some containers actually don't have a width of their own. They're waiting for the child to ask for space. So if you set it to stretch, you're actually as narrow as possible and your control suddenly is invisible.
Yes.
Yeah, so you have to think of these things as playing together with each other. And then there is this idea of, oh, that's the next slide, actually. I was going to talk about content alignment.
Yep.
So the...
this pretty much covers this one.
Yeah, I guess, yeah.
Left, center, right, and stretch.
Yeah, that's the whole deal. All right, set me straight on content alignment.
So content alignment. This is alignment related to the contents of a particular control. So as opposed to the previous set said where a control is within its parent, this is where the content that's being displayed within a particular control is aligned. So horizontal content alignment, again, has left, center, right, and stretch. Vertical has top, center, bottom, and stretch. So if we look at the illustration there, we can see that in this button, we've got the button is set out so that it is stretched across the entire container. However, its horizontal content alignment is also determining where the text that's being shown within the button is being displayed. So pretty self-evident, I think.
And of course, all children are contents of parents, of a parent container. And so if you had a whole bunch of things inside, let's say, a grid, and they're all aligned along the left-hand side, and you wish they were all aligned on the right-hand side, you could go individually and say horizontal alignment right, or you could actually go to the parent, the grid, and say content alignment right, and everything goes because it kind of flows down.
Okay, so we have some additional layout properties. And here we're starting to mention things like framework elements and content controls. So why don't we give us a quick overview of what that is in terms of relationship for controls, just for context.
Of margin and padding.
Framework elements and controls, we mentioned those.
Oh, sure. So there's a hierarchy of all the controls you'll ever use inside XAML, and it goes all the way up to, well, object, obviously, because this is, in the end, just a language. But as you start approaching inside what belongs into your UI, first thing you get to is the framework element, which participates in all the basic properties necessary to be in the platform. So you can start to participate in the render pipeline and other things. So that's the framework element. But as you keep going down, you might go into UI element, you might go into control. Well, eventually you're going to get to control.
Yes.
And control is the base of all the controls you'll interact with. And a control gives you the size, well, all the stuff we've been talking about. Those are all inherited by control.
So one of the key things that we get from our inheritance from framework element is margin. And this controls all of the space outside of a given element.
Yeah.
We also, once we start deriving from control, introduce padding, and that's because one of the things that controls give us is the ability to have content. And so padding then makes sense because it provides a margin internally between the edge of our control and the content that's contained within the control.
Got it. Margin is like a force field.
Yeah.
It's on the outside of the ship. Yeah, exactly.
Exactly. And then we have visibility, which can be visible and collapsed. And so there's some key things here. Other variants of XAML have an additional property called hidden.
That's right, where hidden would actually cause it not to be instantiated. That's not what's going on here.
Yep.
And where when you collapse it, it doesn't take up layout space. That part's nice. Actually, hidden, I didn't say that quite right. Hidden was like collapsed. It would still be instantiated, but it wouldn't. But it would still retain its layout space.
Yes.
So you could hide it, but you wouldn't collapse an area or whatever.
Yes.
Yeah, so that's not there. This is visible and collapsed. Once it's collapsed, it's gone, but it's still being instantiated. You still have the cost of that control. So if you had 1,000 controls, they were all marked to be collapsed, you still have 1,000 controls being instantiated, like it or not. You don't have 1,000 controls being rendered, but you do have 1,000. So don't misunderstand collapsed.
And this is where one of those new features in Windows 10, the defer loading strategy, actually becomes very useful, because if you have lots of elements that you're not displaying, you may wish to defer load. And that's more of an advanced scenario that we're not covering, but it's worthwhile bearing that in mind, that there is an option out there for that.
So we have this nice slide that kind of talks through how padding and kind of margin kind of play together. And so tap once, and let's show where the padding actually is. So the first one is, what if you don't add any padding? What if you don't add any margin? And the second one is, what if you add padding but only to the parent? So in that case, you can see the two red boxes, right?
Yep.
Rectangles. They aren't spaced any differently. Nothing has just happened, right?
They haven't shrunk.
They haven't shrunk either.
What's happened is the padding has been applied space around them, and it's pushed the stack panel out.
That's right. Now, the opposite would happen if I set an explicit size to the parent. Then it would begin to constrain its children so it could give you the padding that you asked for.
And this is part of that layout scenario that we're talking about, where different controls will handle this in different ways.
All right, now hit me again here. So this, I'm going to switch now from padding, this time to margin. So now you can see that even though it looks like you have that space inside the stack panel, what you really have is the space around the individual items.
Yeah, so it's around the first rectangle. So it's had the same impact in that it's pushed out the container around the rectangle. But you'll notice that it hasn't actually applied anything along the bottom of the blue container.
That's right. And it may look like there is a blue border around the bottom one. That's because the background of the outer container is blue. So it's not just to be sure where the margin is.
Yep.
You can't color a margin. So this is what you do.
Yes.
Right. Very nice. Very nice. All right. So that's the difference between padding and margin. It's worth saying that you can put a negative margin to actually move something around. I've done it. Sometimes it's the easiest, nicest way to do something.
Yeah, certainly when there's been some assumption made, perhaps in a control style, that content will be presented in a certain area and it's going to be a certain size. It can be a shortcut to, instead of rebuilding the style for a particular control.
Yeah, if you look at the style inside a text block, for example, where it moves the text around just a little bit, usually it's a negative margin kind of pushing that around.
So one other thing we wanted to mention, although we're not touching on it specifically anywhere else right now, is render transforms. So the name render transforms really gives a clue that this is something that occurs to an element after it, or during the render scenario, but after layout has been calculated.
So this is a manipulation of a child without telling the parent.
Exactly. So if we actually look at the graphic here, what we see is we have a rectangle that's been rotated 45 degrees. And we can see that corners of it is jutting out beyond its container. We can also see that there is still the border, or the padding rather, I should say, or the margin. Oh, goodness. The margin around the first rectangle is still in place and is still pushed out the container. But then after all that layout and spacing has been calculated, the rectangle has been rendered at a 45-degree angle and is now sticking out beyond its
Yeah, so hit it once, and let's highlight the part that is actually doing the twist. And so this is just setting the render transform, not to be confused with layout transform that actually impacts the layout. So
which doesn't exist.
Which doesn't exist, right?
Windows
Again,
10.
it's a little performance issue. So we have render transform, and it allows us to do this angle equals 45. Really straightforward syntax, something that we're used to because we've done XAML for so long, and it's now been introduced even to HTML. We just see this sort of kind of render transform of translate and rotate and all these others. So a neat way to do it. And we were talking about moving things around by margin, right? That's sort of the poor man's approach to using an actual transform, which is very elegant and GPU accelerated, it's worth saying. So if you're moving them around and using animations at the same time, they're handed off to the GPU to do all the calculations.
Okay, so now let's get to what we're actually setting up for, which is layout controls.
Ah, beautiful.
So the first layout control that we wanted to talk about is canvas. And so this is an interesting one. It's very different from all the other layout controls in reality.
Yeah, it's more like maybe something you would use for gaming, to be honest, because it has such a specialized use. You could put something anywhere, including thousands of pixels off screen and then back in because it's as large as it can be. That's the canvas. Of course, setting that left and top is also GPU accelerated, another nice little thing. And probably that, and it's because it fits so well with games. That being said, if you wanted to perfectly control every single thing and you wanted to calculate it all yourself and not rely on any kind of container, there's no better way than the canvas, comma, there's no harder way than the canvas. I mean, there's a lot of stuff that's now up to you, the developer, because you aren't using the other controls that do so much of the dynamic rendering for you.
Yeah, well, I mean, if you wanted to go totally insane with controlling everything, you could go Win2D and bring in DirectX 2D.
Yeah.
And go even beyond the capabilities of this particular control.
You know, we don't have it on here, but one attached property to Canvas is the Z-index that allows you to take a control and move it ahead of another control. Really neat feature, and often developers are looking for, how do I do that in a grid? Really, the canvas is the only place because you can do anything and it doesn't matter kind of where they are to affect that Z-index. After that, it's order in the document outline, which basically just means put it lower in the XAML.
Yeah, the lower in the XAML, the higher
in the Z-index. Yeah, that's right.
Okay, so the next control we were going to look at was the stack panel.
The stack panel. So we already showed a little bit inside the button, putting things side by side. And so you can see in the bottom example down there, we definitely are moving things side by side. You can add as many as you want. And then in the top one, we have them just right there in a line vertically as well.
Yeah.
This is probably the most common control.
It is. It's used very often, and it defaults to the vertical orientation, and you can specify if you want it horizontal.
Yeah, that's right. Some people are wondering, like, what would be the property to make it wrap? And this is not that control. This is the straight line control. The wrap panel would do that, and if you're looking for the wrap panel, you'll need to add your own.
Yes. Okay, probably the most commonly used control, I would say, after stack panel has got to be grid. You know, this is the one that gives you most of your responsive layout capabilities out of the box. You can specify rows, you can specify columns, you can specify a number of different types of height, fixed height, star sizing, when you talk about star sizing.
Yeah, so star sizing, is basically saying fill up all remaining available space. So there you can see there are 5 row definitions. The first, the third, and the fifth are all set to auto. That means whatever content is inside, I want to match that. So the child element in this case might be 100 high, and so if it is, or its height might be set to 100. If it is, then that's what I want it to be as well. But if it's not, if there's nothing here, but all the others are taken up, and there's still 1,000 pixels remaining on the screen, fill it, and that's what the star sort of means. And so, of course, it doesn't say height equals star; it just is blank. But you could have said height equals star. And the second and the fourth one there are both set to star, which really means that they will split the difference.
Yes.
And if you want to make it so that one has double the other, then you could say, is it star 1 or 1 star?
You say 2 star for the double.
And or the number comes first. Yeah. So you would say 2 star and 1 star. Yeah, that's exactly. And you say 3 star or 1 star. This is actually implicitly saying 1 star, 1 star.
Yes.
Yeah, that's right. Okay, so hit it and let's look at where the row and the columns are defined for this red rectangle. We have the red rectangle. We want to put it in row 0, which we're zero-based here. We're all developers. And zero-based means the first row, and 0 column means the first column as well. But from time to time, like the bottom purple one, you might want to make it so not only is it in a specific location, but sort of like HTML tables call span, right? We have grid.column_span, does exactly the same thing. Allows us to stretch across 2 of the columns. Of course, there are only 2 columns in this grid.
Yep. Very flexible control. And as you say, with the star sizing, that gives us a lot of responsiveness out of the box.
Yeah. Real quickly now, I just want to point out the wrap grid. So we have a variable-sized wrap grid that allows us to have just like a grid to move things around like that. And if you look at kind of its structure with this call span and row span, then you're able to see kind of how it's laid out, and you get this default structure based on its item height and its item width. What's different about this and the regular grid is that this is really intended to be used inside a special control, a repeater control, like that's something that's based off of items control, right? So like a list view or a grid view, something like that.
Which we'll be going into detail a little bit more.
That's exactly right. But it gives us a lot of nice flexibility to lay things out while maintaining kind of dynamic control over it.
Yes. The other key thing about this one is it'll wrap as needed by default, or you can specify the maximum number of rows or columns that you wish it to leverage. And the reason why that attribute is somewhat confusingly named, it seems like it can't make up its mind, rows or columns, is it depends upon the orientation that you're using for your wrap panel.
Yeah. Otherwise, they'd have to have or horizontal limit or vertical limit or something like that.
Yep.
Finally, we have this idea of a relative panel. And so we'll just casually say right now that this reduces the complexity of the layout that is necessary to be done inside a control. You'll just have to believe us. As we go into creating a custom control, you'll really start to see how it can become quite complex quite quickly. And if you put 2 and 2 together here, you'll definitely be able to see the draw towards the relative panel for the sake of performance.
Absolutely. So if we look at this, we can see how it can position elements both relative to the panel itself and also to other elements contained within the panel. So in this purple rectangle, for example, we have it using the relative panel.rightOf attached property that says this purple rectangle should appear to the right of the red rectangle.
Yeah, so hit again, and the green rectangle uses another attached property of align left with. So not asking just a position, because really that's just its where it's either X or Y should be lined up. Now we're asking everything else. And so we're aligning its left with the red rectangle. And so now we know that the green rectangle will be flush to the left with the red rectangle. And as the red rectangle moves, so will the green rectangle.
Yep. And then we can go further and then reference the panel itself. And so what we have is the blue rectangle is actually being anchored down to the bottom right. So we've got it aligned right with panel, true. Align bottom with panel, true. And so we can see it anchored down that bottom right. And as we would stretch or contract our UI, then that blue panel will track with the bottom right corner.
Sometimes developers might feel like there's a little bit of extra mental work necessary really to get the relative panel to work inside their applications. But there's a lot of benefits to it as well, especially when you start to consider things like performance and overall tree depth. Sometimes we refer to it as how many controls and things do you need in order to make it look like that. The relative panel can just do it, and it has fewer loops and ways of calculating how.
Which is really what we're going to be talking later when we talk about building out our custom panels. Is you can really see the amount of work that has to go on, and if you're nesting many then there's many recursive calls.
Yeah. So this was fun. So that's the kind of a summary of XAML just as a concept. But then going more into the layout controls, right? Not the controls. We don't care so much about the button in this place. We care about how are they actually laid out. What does the parent do to its children in order to get it to look just right, right? It's really great. And so we've gone through kind of the fundamentals of that. And in an exciting way, I'm kind of psyched to see how we can build out our own kind of logic inside our own layout controls and put the children where they need to be.
Sounds good.
This is all about parenting, isn't it?
It is.
About good parenting, XAML style.